for me here in about 60 seconds.
Kurt, I texted you that you should be able to hit it on your text and dial in.
Just flip the room 90 degrees here.
That's better. That's good.
Okay.
Perfect. And we'll do another quick test of Kurt when he's back. And good morning to everybody who is joining the room here in Zoom and on LinkedIn and Facebook. If you're able to hear me right now, would love for you to drop a hello. If you're on Facebook or LinkedIn, drop a hello there into the chat right now. My team is also going to be there, and we want to make sure that we're all connected. So if you're looking at me right now here in the upper right-hand corner of the screen, please drop a hello. If you just jumped into Zoom, I see a couple of new names here. Drop hello there into the chat. I see Warren just came in. So Warren, good morning. I think good morning to you. If you can just let us know where you're dialing in from and the name of your company, we'd love to be able to read that on the air. Tiffany, how are you doing? Good to see you, Tiffany. I almost called you Tiffany. I've got a good friend named Tiffany, and I'm always calling her Tiff. So I almost reverted back to that, but used your full name there, Tiffany. Hope you're doing well. And folks, in about 3.5 minutes, I'm going to officially kick us off. The panel is here, and many people here are going to be jumping into Zoom, I'm sure, as well as some of the other locations. So in about 3 or 4 minutes, we'll get started. Kurt, you want to do a quick check? How do you sound now? Let's see.
Hear me? Better?
No, it's about the same. Let's see. Are you sure your phone's the one that's picking up right now?
No, the code was for attendees for the Zoom meeting. Kevin gave me.
Yeah, it sounds like it's still coming from the computer.
Yeah, I'm
Good morning, Peter.
I'm still on the computer.
Peter, let's unmute you if you don't mind. Let's do a quick sound check when you have a moment.
You got me?
Yes, say a few words.
Morning, everyone.
Perfect. You sound good.
Great. Thank you.
All right. Tiff has given me permission to call her Tiff. I see Dar. My friend Dar is here. Good morning, Dar, to you. Francois, yes, from Burt Group in Canada. We've got Canada represented. Mike says LinkedIn is good. Facebook or Meta, no problem. All right, Kurt, if the situation remains the same, just make sure you're close to the laptop, and we will definitely make do.
Move that big mug right in front of the camera when you're talking.
And Mike, if you could drop some comments there into LinkedIn, let me just make sure I can see that here on my side. And others, if you're over in LinkedIn land, drop a hello. Let me know that you're here. And we are about 2 minutes away. Hey, Mackenzie. Mackenzie is here. Mackenzie is dialing in from Europe today.
Nice.
Yep. Hey. All right, we're going to officially start here in about 2 minutes, folks. Let me do a quick I just made up a word. A quick last set of checks here. I think we're good. Jessica, I see you over there in LinkedIn. Thank you, Jess. And good morning to everybody who is dropping into Zoom here. I see Scott. I see Robert. I see Johnny. Johnny is my son's name, so love seeing all the Johns here. A couple of Geralds. Frank is here. Drew is here. Douglas is here. Donald is here. Yes, we have Canadians here. Looks like we've got representation from a number of different locations. Awesome. All right, Michael, let's do one more quick sound check with you.
How's it going? Do I still sound good?
Perfect. Yes, you sound
Awesome.
great.
Great. Good.
All right, we got about 60 seconds. Mike, I'm not sure what you're referring to, but it seems like we're okay. I see Suzanne. I see John Andrew. I see Roy over in LinkedIn. Mike, I'm not sure what that comment is there. If you could tag everyone, I want to make sure all the panelists are tagged in a comment with something descriptive. That would be great.
Hear me, Dave?
Yeah, do it again. Let's see.
Dave, can you hear me? The master?
Yeah, that's pretty good. And we've got India, Abhinash. Hopefully I pronounced that correctly over on LinkedIn. All right, folks. Well, I'm going to kick us off here in just a few seconds. Thank you for being here. If you are just jumping into the room here, I want to make sure that you can both see me here waving at you and also hear me. So drop a hello wherever you happen to be right now. Go ahead and drop in your company name. Let us know where you're dialing in from. I'm super excited to be moderating today's panel about the secret to true 3D additive manufacturing with Kevin Carr and the illustrious panel that we've assembled with you today. Our goal over the next 60 minutes or so is to dig into how companies are using 3D printing for what we call true real-world additive manufacturing and distinguishing the hype, all of the buzz around this technology from reality has been a little difficult. There's been a lot of chatter in the industry for some time that 3D would do everything, but that's really not the case. However, there are companies and there are people who are successfully employing true additive manufacturing, and they're seeing phenomenal results. That's what today's panel is all about. We want to dig into what the reality is and understand from today's panel what it takes to create an additive manufacturing process that really works. How do we distinguish the hype from the reality? So because we haven't met, I know some of you are new to the ecosystem here. I want to briefly introduce myself, and then I'm going to bring the panel on and introduce them as well. My name is Dave Rosendahl. I represent Mindfire, and we are a marketing technology company. We partner with MasterGraphics and many of you here in the audience to help you grow brand, drive leads, and generate sales. And I get to moderate these conversations and bring together this community of both 2D and 3D print folks to have conversations like these on a regular basis. So that's who I am, and I'm going to be moderating. You're going to hear me kind of leading the discussion today, but really more importantly, hello, John. I see John here in the audience. More importantly, I want to introduce our panel, and I'm going to start first with Kevin, who is the president at MasterGraphics. And for over 70 years, they've sold wide format and graphic printers, including those made by HP, DesignJet, and Ose, some great brands. But more recently, they've expanded to offer a portfolio of 3D printing equipment from HP, 3D Systems, 3D Platform, Ultimaker. And so if you're in the market for a 3D printer, or if you're wondering, how does this technology help me and my organization? That's what Kevin and his team are all about. And their goal is to really live out everything that we're talking about today, helping companies transform from this hype of 3D printing to reality. And as the company's leader, I know Kevin's goal is to focus on their clients and to help the community really understand how to get value from their investment, including the time that they put into learning about these technologies. And so today's event is very much a demonstration of that commitment. Now, as I was getting to know Kevin a little bit before the event here to bring him onto the panel here, I found out that he also has a podcast. So I want to give a shout out to his podcast. It's called Catting 3D. And Kevin, it seems like you have a huge audience there of 4 loyal listeners. At least that's what you told me.
My mom, my dad, and sisters.
And in addition to that, I know that you also spend your free time caring for your daughter's guinea pig named Mr. Juice. So Kevin, how the heck are you this morning?
I'm doing great. Thanks for having us on. Yeah, the guinea pig is very near and dear to my heart now that all my kids are gone. It's the only thing I get to take care of.
Well, wonderful. Thank you for being here. Kevin, your camera is off. Just wanted to let you know that. Yeah, but I'm sure we'll see you here in a second. Let me introduce the rest of the panel to you now. I'm going to kind of go left to right here on the screen. And by the way, if you just jumped in, please say a hello in the chat. You haven't missed the heart of the material yet. Please jump into the chat, say hello. Let us know your company, where you're dialing in from, whether you're on Zoom, LinkedIn, Facebook, wherever you happen to be seeing us. Hey, Roz, my man Roz is here. I'm going to introduce the panel to you here, and then we're going to jump right in. First up on the left here is Lita Wood. Lita is Vice President of Client Success here at Mindfire, and she's relatively new to Mindfire, but she's not new to this industry. In fact, if any of you know Lita, let us know there in the chat. She has spent around the last 20 years with HP, focused on driving adoption of new technology, both in 2D print as well as 3D. And in all of her roles, she's been focused on helping companies embrace new technologies to ultimately drive revenue. And so Lita's mission is to help companies accelerate their growth. And she does that by investing in community, like the community that's gathered here today, education, and helping business leaders really connect technology, emerging technology, to business objectives like driving revenue and profit. So Lita, I'm glad to have you here with us today. You ready?
I am ready.
Awesome. Well, thank you for being here. Next up on the screen here, you see Kurt. Kurt Schodine is principal designer at Graco, and he has spent the last 14 years there working closely with 3D print to improve the manufacturing process. And as I've come to find, he's highly skilled at looking at challenging manufacturing issues and solving them with advanced additive manufacturing technology. And in his work, he's not only producing functional prototypes, but advanced tooling and fixturing that's cutting lead times down from weeks down to days. And he's improved production processes in a variety of arenas, including casting to machining. So he's really got a wealth of knowledge that I think you're all going to find very valuable as we get into the material today. So Kurt, thank you for being here today. How are you?
Thank you very much. It was good.
Good to have you here. Thank you for being here. Next up is Peter Cootstra. He's the director of engineering at 3D Tech. They're located in Chicago, and in his role, he works with engineers and designers to help navigate the process of utilizing 3D printing for prototyping and tooling, automation, and production. And he specializes in generative design to reduce part cost and volume, which allows their customers to leverage their print farm for production. So Peter, thank you for being here with us today. You ready to get started?
Sure am. Thank you for having me.
Awesome. Thanks for being here. And then last but certainly not least is Michael Rossblock. He's the manager of digital manufacturing at Enerpac. And over the course of Michael's career, he's leveraged additive manufacturing to save businesses millions of dollars. And what's interesting about Michael is that he's not only an engineer, but also a leader in his organization. And he's excelled at both developing tough solutions for tough challenges and tough problems, but also leading teams around executing to meet those challenges. So Michael's current role is leading the research and development of DLMS technologies for applications in ultra high pressure hydraulic products. And they're using HP multi-jet fusion printed parts in production and helping businesses, specifically theirs and their clients, understand their investment in this technology and how it helps them drive outcomes. So Michael, you're ready to dig into today's discussion?
Yeah, I'm looking forward to it.
Awesome. Thank you. All right, folks, what we're going to do today, here's how today's session is going to work. We're going to dive into a number of questions to try to tease apart what we need to know about this important topic. I have here in my hand, let me actually switch camera angles here. I have hundreds of questions that were submitted in advance by you in the audience. And so what I'm going to do is I'm going to start to pose these questions to the panel here. And as I do that, I want you to be asking questions. I want you to be engaging in the chat, whether that's in Zoom, if that's in LinkedIn, if it's in Facebook, wherever you happen to be hearing from us right now. I want to make sure that we're able to see your questions and comments as they come in. So without further ado, Kevin, I'm actually going to throw the first question to you. And I know that as we prepared for the material today, we talked a lot about kind of the hype that has surrounded 3D print. And so for the folks that are here in the audience, and for me, in fact, it's true as well, discerning what the truth is from fiction is difficult. And so I think my first question for you really centers around, do you agree with this, first of all, since you're kind of deeply embedded in the industry? And if you do, why do you think this has happened? And what are some of the biggest misconceptions that folks have?
No, well, again, and thanks, David. I mean, one of the reasons I was excited about this, because I'm a big one of saying hype versus reality. And I think part of the challenge is 3D printing has been amazing technology. And there was just a lot of hype. And I think at one point when we positioned it, we were saying we're going to replace everything. And over time, we realized it's not the case. And I know you're in marketing, so I'm going to be a little harsh, but I think sometimes the marketing blew it, right? So, I mean, if you look at today, that hype versus reality, I look at our three guests today. You take Michael, who now does true additive manufacturing in a manufacturing cell that wasn't available 3 or 4 years ago. Pete's built a business around a service to produce parts using additive manufacturing in the supply chain. And then you have Kurt that's really augmenting traditional manufacturing. So I think if you look back 3 or 4 years ago, we were promising all that. But with technologies, selfishly with HP, but carbon, all these others, we are actually now at that tipping point with our supply chain that's coming to reality. And these guys are perfect example, and gals are perfect examples of the promise finally coming to fruition. And I think we're understanding it better and where it fits, if that answered your question.
Yeah, absolutely. Peter, I'm gonna throw the next one at you here, then kind of digging a little bit further into what Kevin just said. With respect to kind of the hype that this industry has had over the last, let's say, 20 to 30 years. I'm curious, Peter, from your perspective, what aspects of the hype have actually become reality in the last few years?
Yeah, no, and that plays a really large role in what's kind of driving the growth of this recently. The hardware has kind of been there for quite some time, but there's been huge advancements in the material development, which has really enabled us to look at some new applications, as well as the print speeds, the ability to now do volume of parts in a shorter period of time. The HP system being a great example of that, where we can do hundreds, sometimes thousands of parts in an individual run. And that really enables us to now look at doing production. And that's almost entirely how we've been able to build our business.
What percent would you say are prototype pieces versus production pieces, just roughly, that you're seeing right now?
Yeah, I would say it's definitely starting to grow in more and more production volumes. So it's an ever-changing number, but at the moment, we're still probably at about 70 to 80% prototypes, growing into about 20%, production volume. And that is even over probably the past 2 years grown, and doubled.
Excellent. Folks here in the audience, whether that's LinkedIn or Zoom, Facebook, wherever you are, as we're talking about these different aspects here, if we mention anything that you want to know more about, there is no dumb question. Please ask in the chat, and my team and the MasterGraphics folks and the panelists will try to jump into the chat and answer that, as well as take it here on the air. So don't be afraid to ask questions about anything that we say in order to clarify and gain the understanding that you're looking for. Kurt, I'm going to continue in this thread here for a moment, and I'd just love to get your opinion in terms of, this hype that we've been talking about. What are you seeing that's becoming reality now over the last few years from your perspective there at your company?
For us, it comes down to one thing, is pretty much dropping FDM and going with HP. We've seen we went from weeks to a month of backlog with parts, and now with HP, we're 2 to 3 day turnaround. And we're talking 26,000 parts we're at in 1 year with the HP, which, would have been years with FDM. So the material is awesome with HP. That's our biggest thing, is just the throughput with HP.
Excellent. Thank you, Kurt, for that. And you're sounding pretty good now, so thank you for adjusting your mic there. I appreciate that. Yeah. So as we were preparing for this, I'm going to throw this first question to you, Michael. This next question here. We talked about this concept of a 3D print manufacturing cell. And I'd love for you to talk for just a moment, Michael, about what do we mean when we say cell in the context of a 3D print manufacturing organization. So Michael, help us understand that concept here and why it's important.
Yeah, let's just compress the last 3 years of my career into a minute and a half, 2 minutes. No, I'm just kidding.
Sure.
It's a tough question to answer, and I think if you just Google what is a manufacturing cell, it really gets into Kaizen, just in time, sort of like a modular component of a production site. They'll talk about it that way, and how I really like to think about it is for whatever you're producing, it's got everything you need to bring that product, whether it's assembly, machining. That cell is all of that component of a process for producing a physical component, lives within that cell. And it's really, and by production, I think is really the heart of this question. What does that mean? As someone who tried in my company to run an FDM print farm. And I tried to make that happen. It was my dream coming out of college. The problem ends up being reliability, the amount of time you're spending on the weekends, coming in, fixing machines. You need something reliable. That sounds like fun for a while until it's been 9 months of coming in on Sundays, Saturdays, staying late, fixing machines, parts not sticking to the bed. You need something reliable. You need something that is gonna, just reliability is really the biggest key piece, and throughput, like everyone else is saying, along with that material property, being able to produce a production grade part. I always say you've got to be able to produce a good quality part first, and then you worry about the cost and the throughput. And I think HP meets that. If you go get your sample part, you'll find that it likely will blow you away with how good it is. And then the business math just comes later on from that. But a little bit of a roundabout answer to that question, but hopefully that makes sense.
Yeah, definitely makes sense. I'm curious, Kurt, what's your view of this? Would you describe it the same way as Michael did, or do you have another perspective on this?
Ours is a little bit different here. So we design, manufacture, and market OEM parts. So everything has to go through engineering first. So manufacturing, they can buy a machine, but we have to prove it all right, because you're making your parts lighter, stronger. We have to retest them in engineering before they can go into manufacturing cell. So that's what we're currently doing now, is we probably have about 20 parts that we send to manufacturing, but we run them all here in engineering and we tested them. So it's coming down to pretty soon they're going to have to buy their own machine and then start their own cell over there.
Peter, what about you? How do you define manufacturing cell?
Yeah, and I think this is kind of interesting because it highlights how different companies and different profiles, look at this. And because for us, best way for me to describe it is a flexible manufacturing setup. We might be making parts for a company like Graco one day and then have to turn around and make, marine products the next. And sometimes that involves assembly. Sometimes that involves, heat set inserts, and sometimes, things like different surface finishing options as well. So we need to be able to pivot pretty regularly during the manufacturing process. So when we refer to a manufacturing cell, it's intended to be flexible and be able to kind of find the solution for the customer, whether that be, matching a black color or just being able to assemble an actual component as well.
Well, Peter, I want to keep you on the hot seat for a second. I'm going to dig into something there that I think is definitely of interest to me, and I think many here in the audience. I saw a number of questions come in around, this idea that traditional manufacturing has many standards and many defined processes. And so the audience is curious, and I'm curious if you're seeing the same kinds of standards being implemented around 3D. And kind of related to that, then, what kinds of volumes are you able to economically produce through the configurations that you work with? I'll start with you, Peter, and then I'll move on to the others and see what their views are on that too.
Yeah, the biggest thing that I've seen, and maybe one of the reasons why, there's been some pushback on adoption is that people are trying to apply kind of existing quality methods or existing production mentalities to 3D printing, meaning we'll get a lot of 2D drawings that have materials called out on them that are not specific to this process. So one of the biggest advancements that we've seen in enabling production for 3D printing is calling out the specific HP material on your 2D drawings, which helps better define, what you're actually looking for. Then actually reviewing the tolerances on that drawing. We get a lot of over tolerance drawings to where, that's just not a manufacturable part for this process. But after a half-hour meeting with an engineering team, we're able to get it dialed in, and that's an easily producible part. So looking at it through the lens of not just, well, I've always toleranced my parts this way, or I've always used just an HP or just a PA12 material, but rather calling out the actual HP specific material on your drawing, getting it set up so that companies like Enerpac have that in their system for, the history and the duration of making that product. And then from there, one of the things that's helped enable it is, for us at least as well, is an open communication with the customer as this is being produced. With additive being so new, we have to kind of jump on new challenges as they present themselves. And in doing so, we've been able to kind of grow our production volumes to where we're now doing roughly about 20 to 30,000 production parts every year.
Every year. Okay. Very good. Michael, I'm going to ask you the same question here, but I just wanted to mention that I see TJ. I see your question here, TJ, in the chat. And folks, keep those coming in. And my team's going to pull all those together, and we're going to leave time towards the end to get into those questions. So please continue to drop those in. Michael, my question for you is similar to what I just asked Peter. From your perspective, what volume are you able to economically produce?
Yeah, that's a good question. So I know Pete likes to talk in number of parts. And I know a lot of people like to look at it that way. I tend to look at it like cubic volumes, like pounds of plastic produced. Just depends how you like to look at it. We produce a lot of larger parts. So we'll do a lot of like shrouds and things, like injection molding replacement shrouds. And those can be 2 parts per build, but they're huge, right? So I don't know, we're producing, what is it? 20,000, 25,000 pieces per year is what the run rate is right now. Looking at, utilization rates, somewhere in 30 to 40%. So looking pretty good that way. And that's all based on a lot of assumptions and a lot of math that way. But yeah, that's kind of where we're at on that. Do you want me to touch on this industry certification question quick or?
Yeah, go ahead. Let's touch on that.
Yeah, I was gonna say that was what I started off with because you start off in engineering and say I found this really cool new printing technology, and they're like, okay, well, what about UV certification? What about moisture absorption? What about long-term reliability? What about, so it's all those what abouts, and I think HP and the industry as a whole, initially go, yeah, we're ready for production, and then all those questions come up like, are you ASTM certified? This, and this. I think at first there was some of that had been done, maybe not to the level of detail that people were looking for and like really understanding. Because you work with injection molding suppliers and they go, yeah, you can order UV or fire resistance of this and a UV rating of this and impact modifier that, right? And that just ends up on drawings from 40 years ago and everyone's okay with it, right? And then people hold a little more scrutiny though, I think, to a new process, right? They kind of say, okay, that sounds great, prove it, right? What'd you do? What was your testing? Can I see your test reports? What was your sample size, right? And those are, when you start getting into the white papers from HP and stuff, I just think that the data is there. Depending on the level of scrutiny you take to it, it either will satisfy your requirements or you might want to do some of your own testing, or you might need to set up a call with HP and talk with the engineers who ran those tests. I implore you to really look at the standards that you're holding and make sure that you're being equivalent between your injection molding suppliers and your printing suppliers. I guarantee that there's some more leeway on those injection molding suppliers than you realize, and you're probably over scrutinizing your new additive suppliers just because you're not familiar with it. So that's what I would say as far as those go. The material holds up is what it is, right? It lasts in outdoors and really performs really well. So
let me just clarify for everyone who's wondering, Michael's responding to a comment here in the chat from TJ Hendrickson saying, are industry certifications worth it? I teach this and I'm always looking for a leg up for students. So TJ, thank you for the question. If anyone else has any input on that, even in the chat, just go ahead and drop that in the chat, whether you're on Zoom, LinkedIn, or Facebook. And let's see if we can get TJ some help. Kurt, before I move to the next question, I want to ask you as well, similar line of questioning here around what kind of volume, what part volumes can you economically produce?
Pretty much with the HP process, it's unlimited. We're taking parts out of manufacturing that are injection molded and cutting the cost down about 1/3, and we're doing anything from 300 to 2,000 parts on this machine, all while supporting engineering at the same time in manufacturing. So 2 to 3 day turnaround by the time it's cooled, blasted or dyed and out the door, and it's just unbelievable. So it's pretty much unlimited with the HP system.
So it sounds like it's been fairly successful for you, and that's kind of my next question, Kurt. I'll stay with you. Give me your top, let's call it your top success, or the thing you're most proud of from implementing additive manufacturing. If you look back over the last couple of years, what's something that stands out to you as one of those shining moments?
So for us, I'm in specifically new product development, so we have to keep our customers happy, right? And this is a part here, if you can see it, it's a wet cup that has threads in it. And, $25,000 injection mold, we only need 500 a year. So we just print them. The lead time on the outside, this is an MPT thread right here. It's 84-day lead time on the outside. So with HP, you're able to print that thread, done, and put them in the blaster, dye them, and send them to manufacturing in a matter of days. So it's just crazy that this technology is out there. But for me, it's definitely cutting down new product development time.
Awesome, folks. If you want to see that, I'll have Kurt pull that back up on the screen again next to the camera. Thank you for bringing the item there. That's helpful. Yep, there we go. I don't know if you can see that there, but thank you, Kurt. Peter, what about you? Give us a highlight, a success, something that you've seen from the last couple of years in terms of implementing additive manufacturing in the way we've been discussing here. What stands out to you?
Yeah, we have been very fortunate to work with some really incredible and big name companies on developing out, actual production products. And, the first thing that I'll say is it's not a quick process out of the gate. Michael had kind of mentioned it, is that newer technologies, especially internally, with some engineers that have been there and used traditional manufacturing methods for a while, usually have quite a bit of a pushback on it. And the specific project I'm talking about here was about a year-long development cycle. Now we only do about 10,000 units per year with them. So not a huge product in relative to what they do, with some of their other products. However, it's a very specialized niche product. And one of the things that I love about my job is what some of these products end up doing down the road. And so this is used for industrial kind of pipe scanners to in the gas and oil industry. So helps in the long run provide a lot of resources to individuals. Here in the US, it's kind of, we take it for granted, but around the world, being able to have access to renewable sources like oil and make sure that that's safe all starts with being able to scan that pipe. And so the products that we make end up going on to that pipe scanner, and it's a very complex product. They were able to design it in a way that they weren't before. And in fact, when we had started out, 3D printing wasn't even at top of mind. They weren't even looking at it for a production method. But when we looked at the yearly quantities, it made sense. And to Michael's point, a lot of times the parts do the talking. So it started out as a prototype opportunity. I just printed them an HP part, sent it to them, and the next thing you know, we're on a year-long journey to do a production part.
I see Chuck just mentioned injection molding here in the chat, and that's actually a good lead into my next question. I'll direct this first at you, Michael, and then I'm going to probe the rest of the panel as well. I'm curious if we can talk for a moment about how you see 3D printing sitting alongside or complementing traditional manufacturing. We hear a lot of comparisons to injection molding, and I'm just curious as to your thoughts on that. Let's start with you, Michael.
Yeah, I'll touch on one other thing I saw in chat too. We're talking about mostly the HP Multijet 5200, 4200 series, or 4200 series, as far as what printer we're talking about. I don't know if Kevin wants to show a picture of it or drop that in the chat or something. I'm personally running the 5200 series, love it. I think Peter's got a mix, and Kurt, I think you're still on the 4200 series. So anyway, that's just wanted to answer that quick. But along with that, how it sits, and I saw some other comments in chat. Yeah, I think additive definitely lends itself to lower volume, high complexity, short lead time, kind of reactive. We'll call it like pinch part production at Enerpac. So, and with the world as it is right now, I mean, everyone's dealing with supply chain issues, right? I mean, additive is the perfect solution if you are using, plastic components for your business. Additive is the perfect solution to fix those problems. And you might end up with parts that the part cost is higher than an injection molding part, right? If you have a tool that was made 10 years ago, it's fully amortized, and you're just running parts out of it, yeah, you're getting the benefit of that scalability, all those things, right? But the tool breaks, there's a rev change, there's any other issue like that, or parts are backed up in port or whatever it might be. Additive can spool up like that. And I think Peter was talking about flexibility, and that is absolutely huge. As someone who writes business cases for this stuff, I kind of call that like a soft cost savings. And it's really hard to like financially put on a piece of paper and write down what the value of that is. But when you save millions of dollars in revenue of shipments at the end of a quarter, at the end of a quarter that you were going to miss without these parts, nobody's questioning, does the printer pay for itself? So that would be kind of my comments on that.
I see Chuck is asking for an email address that he can send a photo of the part that he's looking for. Why don't you, Kevin, why don't you drop your email address there into the chat and you can kind of triage that. And also for the rest of you, if you have questions or if you want to talk to somebody on the panel about anything that we're discussing today, towards the end, we're going to drop a link into the chat and it'll have a little form there that you can fill out and we will get you connected with the right person. Lita, I don't want to skip over you here. I want to get your perspective on the question that I just asked with respect to, how 3D printing sits adjacent to or complements traditional manufacturing. What are your thoughts on that?
Actually,
Lita?
my favorite, can you hear me?
There we go.
There
Yes.
we go. My favorite's end of life, actually. So you can be producing a part on injection molding or what have you, but when you get to end of life, you don't want to have thousands of parts sitting on a shelf. What you do want to be able to do is to deliver to your customer on demand a part, and the price doesn't matter so much. So for me, it's always been end of life and being able to see, the value of not having to store those parts somewhere all around the world.
Got it. Kurt, interested in your thoughts on this. How do you view the two sitting next to one another or complementing each other?
Yeah, I think they work hand in hand perfectly. You get injection mold right now. The lead times on tooling is crazy. The cost of them are through the roof. 4 or 5 tools, you're over $100,000, and you design it. Use a little DMF generative design in it to lighten up the part and make it stronger, which obviously you can't injection mold. It works great sitting alongside, and like we said, if a tool breaks or end of life, it's really great to just pick it up and redesign it a little bit and get an HP, and it's running in a matter of days. Hours,
Peter?
I should say.
Hours? Okay. Peter, what about you? Let's wrap up with your view on this, and then I'm going to move to the next question here. So kind of just give us your sense for how the two complement one another.
Yeah, and that's, if I had to describe my job in just pretty much one sentence, it'd be kind of boiled up into this, where we have to evaluate what is the best, manufacturing technology based on the part and the 3D geometry that I'm looking at that a customer has sent. And so we have to look at some scenarios where, one beats out the other. And in some instances, it's actually a combination of both. So applying, traditional manufacturing methods with 3D printing is also pretty important and something to keep in mind, because it just requires you to look through maybe a bit of a different lens. And maybe a good way to describe this is the scenario that everyone else is in right now with COVID, where supply chain has been disrupted. If you don't have access to your parts, it makes a lot of sense to look at a backup or an alternative manufacturing method rather than no production at all. So in some instances, we're working with companies not to prove out their production part, but to prove out the backup production method, so that if they all of a sudden can't get parts for 60 to 90 days, we have a way of actually being able to backfill and provide that to the customer.
Yeah. So Peter, that was kind of my next question. Supply chain issues are definitely clear, right? I mean, we're seeing those in all sorts of different areas, 2D, 3D, even household items. Obviously, it's affecting us across the world. So you touched on it briefly, but is there anything else that you would want to say to everyone here around how 3D printing is able to help us and help companies address, these challenges?
Yeah, absolutely. And it was mentioned earlier, being, the storing something on a shelf. And one thing I'll kind of pose to the audience is to think about how much it costs just on a yearly basis to store an item up on the shelf. And we're seeing it now, like you'd mentioned, with the supply chain issues. But a lot of people look at it as, well, we just need to throw more on a shelf to be able to have there available, in the long run, if we have these, peaks and valleys of needs. However, it is very expensive to just keep something stored up on a shelf. So just saying, hey, we need to keep more to be able to ride out the storm of COVID might not be the best approach. In some instances, if you have huge peaks and valleys to your quantities demand, a technology like 3D printing is going to be a perfect fit, because we can turn around, be able to provide 10 parts in a matter of days, but also 10,000 parts in a matter of days. Some people are a little surprised when we provide quotes back and our lead times are the same for one part as it is for that 10,000 volume. That instantly forces them to start thinking about, well, how can I use this in my supply chain?
Kurt, what about you? Insights on supply chain challenges and 3D printing addressing some of those challenges. What's your view on that?
Oh yeah, it's the same deal as, like this wet cup part was 84-day lead time to machine it, which is crazy, right? So it's definitely no parts on the shelf and it's on demand. That's the biggest deal.
Lita, what about your view? I know you've seen a number of organizations. In fact, yesterday we were just in a meeting where we were hearing from a different industry, but similar challenges. Everyone's got this challenge. So how do you see 3D helping to address the problem?
I mean, I'm repeating the same thing in some respects, that really there's disruption now, but there's disruption all the time, right? And so companies shouldn't just now be thinking about this. They should be building it into their plans to always be producing a 3D design, at least, even if they're going to do something on inkjet. They really need to have that plan in place. Something to be thinking about all the time.
I want to ask the next question of the audience to help me pose this question to the panel here. Who here in the audience is considering making an investment in 3D print? I want you to go drop that into the chat right now. If you're in Zoom, if you're on LinkedIn, Facebook, wherever you happen to be hearing from me right now, who's considering or trying to figure out if this makes sense for their company? Drop that in the chat. I want to see who's got this on their mind, because Michael, what I want to ask you, I'm going to start with you, is, if you can kind of share with us, how do you justify the investment in 3D print to management? In other words, if there were any lessons learned through this process that you've been through to build the business case, what kinds of insights would you share with somebody who's considering doing the same thing?
Yeah, I could. Well, and I have. I could do the whole panel just on this topic all by itself for at least an hour. I mean, it's complicated. It's super specific to your business, your needs, your executive team, who's the purchase. What's your experience with additive? I would say go get a sample part made from a service bureau, right? Call up Pete. Get a part made. Are you does it work for what you need, right? Do you need ultra, space age, carbon fiber, crazy temperature, whatever plastic, or does nylon 12 work for you, right? And I think that's the first step, is say, does this process, is it feasible? Is what we're looking for? Go find the machine that does that, and HP might not be the right solution for what you're trying to do. It's not metal, right? If you need steel parts, sometimes you can replace them with a plastic or aluminum, but you need to go find the right technology for what you're trying to do. In my opinion, I think, do that engineering research up front, get a couple parts designed, get them in the lab, build some confidence around the technology. And then would just sit and wait for the next big problem to come up, right? In my business, we had supply chain disruptions. We were able to solve them very quickly. Saved millions of dollars in revenue, and away we went, right? Other businesses might have a whole portfolio of products that they're like, if we had this machine, we could produce all this stuff. It would be great. We'd take out inventory. We could stop, we could obsolete some of these things and sunset this product. You might have a whole portfolio of parts that you already know, and I would call that a more traditional business case. Then just go buy work with a guy like Kevin or Pete, figure out how to run these machines in production, bring them on your site, and just go get it, right? And that's just a couple of different ways to tackle it. I'm sure the other panelists will say similar things or have a few other different stories, but I would really base it on that. Yeah.
I'm gonna ask you, Kurt, to give us your perspective on that, but I want to read what some of the folks here in the audience are saying. Lee, remind me what company you're with. Lee says, I'm a hobbyist now with 4 printers. Not sure if it makes sense yet, for our commercial print company. So Lee is in the 2D print business, it sounds like. And Lee, forgive me, I'm not remembering your company name, but let me know so I can read that out here. Dar says, not yet considering acquiring equipment. We work with one additive manufacturing in Toronto. Drew is saying, I'm trying to gauge when it's a good time to get a small printer for replacement parts when we don't have a traditional part on hand. Lee is with Abco. Okay, got it. Yes, that's right, Lee. Thank you. All right, Steve, I'm going to get to your question here in a second, but Kurt, would love for you to give your perspective on what your biggest lesson learned is that you could share with the audience here around building a business case as to when to make this investment and how to make this investment. What's your view on that?
So for us, it's, you got to have cost savings to do a CER, capital equipment request. So we took 3,500 parts out of our model shop with machine, they're over $100 an hour. We took those, and then we took outsource cost, which is, could be up to 10 times more than doing them in-house. And then of course, switching from FDM to HP, it's the price of the material cost is way cheaper. And then the runtime is, 25 times faster. So we took all that, came up with the CER for the big wigs here, and they approved it, no problem. And then we came back a year later, and out of those 3,500 parts, we actually ran 19,000 first year. So our CER came way down on that. So that's how we do it here at Graco, cost saving.
Peter, what about you? How do you build the business case for the investment in this technology?
Yeah, well, at least for us, we probably have the easiest justification because that's our whole business. But what I can say is we help companies all the time make the justification. And one thing I want to clarify too, we're your friend in this whole additive journey. Some people look at us as an outside supplier. We always want to retain that. But the reality is a lot of our customers actually have printers, and we have helped them to actually decide what printers they want to go with. And you'd be surprised that even some of the big name companies that reach out to us and they've spent 3 months doing development on a part that they want to get FDM printed, and they go, we validated the material, validated the design. Can you give us a lead time on getting this part printed? And we'll come back and be like, well, if you're going to do that in FDM, it's going to be 2 years before you get your parts. And if it's HP MJF, we can get it to you by the end of the week if you're looking for it. And they realize pretty quickly, like, okay, well, maybe we don't have to go the FDM route. Maybe we can actually go, an alternative route. And we'll sit down and go through the individual part costs, what it actually entails to make that individual component and accomplish what they're looking for. And from there, it's going to be a natural decision on their part, whether they bring it in-house or continue to outsource it to a company like us. But even in that scenario, when they do bring a technology in-house, we can be their backup supplier, right? If the production volumes hit, to be too high, we can just take that build file that they already had developed internally and plug it into our process. And so they can, really quickly double the capacity that they have available. And that is really just a testament to kind of the growth in the technology in the industry.
I want to give everyone an opportunity to visit this URL here on the screen. My team's going to drop this into the chat here before I go to the next question, because I've seen some questions that have come in that I think require a little bit more discussion. So I want to give you an opportunity. If you paste this into your browser, and my team's going to drop it into the chat here, 3d.mastergraphics.com. When you go to that page, folks, this is what you're going to see. There's a little form there on the page. If you want to talk further with Kevin and his team, if you have questions for anybody here on the panel, fill in this form and we will triage all the requests that come in and then get you connected with the right people. So if someone here on the panel has said something that has piqued your curiosity, if you're thinking about whether or not this makes sense for your business, if you're trying to figure out how to solve a challenge that you or potentially a client has, then take a moment, jot down this URL. My team's going to drop it there into the chat. Go in and fill it out, and we'll make sure that we get you connected with the right person so that we can answer your questions. I want to leave enough time here on the clock to be able to answer questions from you here in the audience. So if you have something, please drop it into the chat. I see a few are in there. My team's going to pull all of those together, and I'm going to read them out here in just a moment and try to get through as many as we possibly can. So as you're doing that, I'm going to ask, let's start with you, Kurt. I'm going to ask you a question here just give me real quick one thing that excites you about the 3D space as you look out over the next, let's call it 12 to 24 months. What's something, Kurt, that you're excited by that you're seeing right now?
For us, it's going to be metal printing coming down the road. We do a lot of investment castings here, and the lead times are crazy. The suppliers they're just all backed up. So definitely metal, and not the laser, the $1 million machines, but the sintering metal printing is going to come around here pretty quick, I think.
Peter, what excites you 1 to 2 years as you look ahead? What's on the horizon that's got you excited?
I'll be a broken record and say metal as well. That's really my love. And we do actually offer every metal printing process available in the additive space right now. So that includes E-beam, DMLS, the Markforged Atom process. And we're learning a lot on the sintering end, but there's going to be some huge advancements in the available materials, as well as some newer technologies rolling out there that it's going to be really interesting to see where it goes.
I see some folks are taking an opportunity to talk with Kevin and his team. So make sure if you want to speak further, when you type in this URL or when you click on it here in the chat, go ahead and fill that in so that we can make sure that we get you the help that you need. And I will try to answer as many questions on the air as possible. Michael, I'm going to turn to you now as you look ahead over the next 12 to 24 months. The world is crazy. Things are changing every day, but what excites you that you see ahead and around the corner?
Yeah, it's going to be metal from me as well. Personally, for us, as far as hydraulics go, DLMS is a lot more mature, a lot more developed as far as material properties go. And that's what we're really looking at, actually investing into in the next little bit. I would probably put the sintering technology. I might be a little bit, I'm usually pretty gung-ho about all this stuff, but I'm going to say sintering is probably not quite 2 years yet. I'm thinking it's going to be a little longer for material specs and all the process capabilities that come together on it. But I think it's the next 2 years is probably the right time to start working with it if you want to be, ahead of the curve, or with the curve, I should say. But I'm excited for that technology too. I think Kurt said, casting replacement. I think it could be an awesome fill-in for any of those parts that plastic won't quite cut it, but you don't need Inconel, you don't need titanium, you don't need that level of part. They have a lot higher throughput, they scale a lot better, the cost per pound is way better with those sintering technologies. And I think they're going to be ready to go for prime time, probably early investment and starting to work with service bureaus in the next 2 years. And then I think they'll really trickle down from aerospace, medical, and hit kind of more manufacturing level within 5 years for sure. That's my guess anyway.
Very helpful. All right, folks, let's get into the Q&A now. And so the way we're going to run this panel, I can see you in front of me. So wave your hand if you have an answer to these questions that I'm about to throw at you. This has come from the chat. So regardless of whether it's LinkedIn, Zoom, or Facebook, my team is going to be pulling this, dropping questions in so that I can see them. And if you've asked a question as we've gone through the material today and we haven't, for whatever reason, answered that, go ahead and repaste it back in just to make sure we don't miss it. So I'm going to pull a few here. The first one is for Tyson. So please, panel, wave your hand at me when you're ready to answer this. Tyson is asking, what secondary operations for support material removal, as well as the surface finish modification, have you utilized for end-use parts? So who's got a good response for that one? All right, Peter, go ahead.
Support structures are, can be very tricky. We have every hand tool you could ever imagine. And surprisingly, finding the right style of picks, being able to get the support structures off can be quite difficult. So I can probably follow up with a link to a few different items that we use for support removal. But I would say as well, on the front end, taking some time to design out customized support structures can save you sometimes hours, days, it feels like, in removing it when you're doing production parts.
TJ is asking again here, and I think this is good because this is an aspect that is really important as we invest in the future of this technology. TJ is saying, what are things for students to help them learn that's going to help them in rapid prototyping and fabrication as they develop into industry positions. And so obviously staffing, finding qualified resources is very important and challenging for many industries situation right now. So what are your thoughts, panel? Go ahead and let me know who's got a perspective on this. Yeah, Kevin, I'll go with you and then I'll go to Michael. Make sure to unmute, Kevin.
Yeah, I got it. No, sorry, Michael, to take it, but I would say, especially, one of the things I'm very bullish about is people like Michael and Peter. Sorry, Kurt, you're older like me, but the younger generation coming up. And if you look at, like, even in the Midwest, the MSOEs, the Northwest Technical Colleges, there's beginning to be courses that are designed for additive. And what I'm personally seeing is those courses are training the skill set that we need to really implement it. So that's what I get excited about. So if you are in that, you want to be in that realm. I know Pete went to MSOE. I can't remember, Mike, where you went, but I think that there are programs out there, and we truly, almost everyone in the industry has taken some type of specialized class around that. And it's been, like I said, to me, hugely beneficial for those students to come in and impact our industry at a very young age. It's their opportunity to grow and replace us older guys.
Michael, why don't you give a retort to the old guy there? What do you think?
Yeah, I'll say, go Gophers here over here. And now that we've got our axe back, it's all good. So, MSOE, great college too, though. Yeah, I would say so. I came from the school of, I bought a printer when I was 18. Before I went to college, I was printing parts for kids, and I was running a little business. And I just learned by doing and I really recommend that. I mean, back then, the lowest cost FDM machine was pretty expensive. Now, I mean, for $200 or $300, you can get a Creality something system. Go get one, start playing around with printing parts at home. I think learning by doing is the best way to go. If you're in engineering or anything like that, all the old guys are looking for someone to run the printer at the office, right? And I think that's where I started, right? And I think that's learning by doing is always my favorite. And I translated from FDM into going to a trade show is really what opened my eyes up to what industry is, what I'll call industrial 3D printing is. And I just went from there, started asking questions, and I've always been passionate, excited about it. So that's what I'd recommend. But yeah, there are getting to be lots of, college courses. MIT puts on a nice additive, MIT, it's like Pro X, I think, or something. And I've taken a couple in metal printing, which those were really good as well. So yeah, I mean, if you want to get into this, it's, I think some colleges have like a class or two on it, but you're really going to have to lean into it. Go ask questions, go find people on LinkedIn, attend webinars, buy a machine yourself, right? Just get started.
Here's a little bit of a detailed question. I'm going to throw this at you, Kevin, and if we don't know the answer necessarily, we can follow up on this. But this is a question that came in earlier from Tyson. Does the HP MJF printer have UL94 flammability rated V0 material options, Kevin?
And I'm not the AE, but it does not have a V0 rating at this point, right? I mean, it's one, we get that question all the time. I'm sure all three of these guys get it. There's some work on it, but I think because of the technology, particularly MJF is harder to do versus like an SLS would have a V0 rating, if I remember the right, Pete. But that's again offline, a good one to follow up because there continue to be advancements.
Okay. Supply chain related question here. This came from Steve Martin. I'm sorry, Steve Marvin. Forgive me, Steve. With supply chain issues, are you seeing any issues with getting the actual material to print parts? Anybody seeing that? Wave your hand here at me.
No.
Anybody seeing that? No, Kurt?
No.
Okay. Anybody seeing anything? Well, looks like everyone's. Kevin, what do you have?
Yeah, no, as a vendor, I would tell you we have not had that issue. It's concerning, right? But we have not. I mean, I think some the actual machine equipment has been a challenge as it's coming over, like finishing that. But it's interesting on the powder perspective, we haven't run into it. I mean, in the world we live in, it's not like I don't think about it, but we've been pretty stable from that perspective. It's probably more affected the equipment.
Question from Tyson here. Does anyone modify surface finishes with secondary operations for aesthetics or texture of end-use production parts? Peter, go ahead.
Yeah, so we actually have the AMT vapor smoothing system as a surface finishing option for some of our thermoplastic parts. Works great on the HP parts, and we many times we'll just send in a nice sample to a customer that orders an unfinished unfinished surface finish part, and more often than not they come back and want to use that for their production method. It's an easy way to get an injection mold look on a traditional HP MJF part.
Excellent. Kevin, I'm going to throw this next question at you here. We've talked a lot about HP equipment today. Curious your perspective on that. I did see somebody in the comments say, hey, is this an HP commercial here? And so just love to give you an opportunity to address that and talk a little bit about the HP technology and why it's come up so frequently today.
Yeah, so I was going to actually address that. In fact, I think I know Mark very well, so he's putting us on. But I mean, when I look at it, I'm passionate about HP in the sense that the reason, unfortunately, it's come up a lot is all these panelists have changed their businesses using HP technology. But and we resell it. But I think technology like HP and carbon, when you look at that throughput that they're talking about, like Kurt is very hard on FDM. Carbon and HP in particular created a volume you couldn't have done before. And look, we're going to continue to see people like Stratasys come out with competitive processes because of what we're seeing from a payoff perspective. So yeah, unfortunately, I always hate when this comes across because it sounds like an HP commercial because we're passionate about it. But we realize different technologies fit in different ways. But in this case, again, in particular, HP and carbon have changed that production scale that we haven't seen. And that's why you're continuing to see the investment from others. The other question I think that was in there, Dave, is just overall cost. Look, we are talking production units, right? So you're looking, starting at $100,000 up. And that's true whether it be, again, us, carbon, Stratasys. And so it is a bigger investment, but the return and the throughput is there. The cost to run it is lower. So that's one when we're getting back to ROI, sometimes we look at that purchase price and we say, oh my gosh, it's $200,000. One of the challenges I think like we've done in the 2D side, we look at it a monthly base, like a lease or a rental or some type of program. So I encourage you to not focus on that initial price, but what's the payoff long term, right? And how you do that. So hopefully I answered that and added something else to it because I didn't want to avoid that question either.
Who asked that question? Do you remember, Kevin? Well, you're on mute. Say again. I think it was.
No, I know Mark asked the one about the HP commercial. I can't remember who asked about the price investment.
Okay. All right. TJ's got a follow up here asking about the interface. I think he's wondering about the ease of use and teachability of, say, GrabCAD versus HP systems. Who's got a good answer for that? Kurt, looks like you threw a response there in the chat. You want to add to that, and then I'll go to you, Peter?
Yeah, the 3D Build Manager software that comes with it is awesome. Load your parts in there. You can hollow them out if you want to, and push one button and send it to the printer. Same as GrabCAD. Sounds
easy. Peter, what about you? What are your thoughts?
Yeah, this is another area where there's been huge advancements, software. So a lot of the different softwares are converging on kind of same functionality. Two others that I'll just mention are going to be NetFab and Materialize Magics. If you're going to look for the industry standards and kind of where this is heading.
Excellent. Now I want to ask the audience a question, folks. Get those little typing fingers ready. It's going to take you a moment to think. So go over to the chat, load it up, and here's what I want to know from you. What was something that you heard today, something that you learned from any of the panel here that has stuck out in your mind? What's the insight, the takeaway, something that you learned that was impactful from what the panel shared today? Go into the chat, drop that in there. I want to be able to read off a few of those and see what resonated with you today. For example, Tim here is saying, I see Tim over here in Zoom is saying Metal 3D is on the rise. Yeah, we heard that pretty unanimously across the panel here. What else, folks? Drop that into the chat. And as you're doing that, I want to give the panel one more quick opportunity, folks. Give me a 10-second, 15-second answer here. What is something that nobody asked today that maybe I didn't bring to the table here that I should have asked you about 3D print? I'm going to start with you, Kurt. What's your thought on that?
Mine would just be the cost of running the parts. It's like keep reiterating that, but low overall cost to run parts and get them out the door.
Okay. Good. I'll dig into that some more next time then. Peter, what about you? What should I have asked that I didn't?
What part should you be 3D printing? And we get that on our end quite regularly, and we usually end up settling on not at all the part that they had initially thought that they should bring to our attention. So it's a great scenario where we can again work with those people and help address that question and in the right way answer it.
Michael, what about you? What did I fail to ask?
Maybe we did kind of touch on it, but I just think if you're going to talk about additive manufacturing production, I think we could have focused more of the conversation around like, what does it mean to really set up and run a business, right? Run a production industrial 3D printing cell. I think we touched on it very briefly, but let's just say you're an engineer or a hobbyist or an enthusiast in the technology. Running a production style business with managing employees and schedules and hitting on-time delivery and all those metrics, that is a jarring experience. I can say personally, going from the world of engineering into managing an operations level business. And if you're considering getting into this type of system, really think about that. Go learn, go talk to somebody who's done it. And I would recommend that before jumping in. Because it's not an easy thing to pull off. It's not impossible, but it is tough.
All righty. And Lita, what about you? What should I have asked? What should we have talked about that didn't get raised today?
Whole different topic actually, but 2020 really brought 3D to life, I think, in most households. And so it's a great time to be talking to your local governments and state governments on investment dollars that they might have, some of the new rollouts of dollars. And really talking to them about producing locally and helping with the supply chain issues. Big thing to be thinking about right now.
Well, I want to thank the panel here. I want to be very respectful of their time and yours, folks. So I'm going to put this URL back up on the screen one more time. And if I could get my team, looks like Mike Chercuzio has dropped that into the chat. If you, team, could drop that in. And folks, if you have any questions, I've seen a number of these requests come in. Go to this URL here, 3d.mastergraphics.com. And get some time on the calendar to talk to Kevin and his team. And we'll take care of any additional questions that we didn't answer by you going there to that URL. Thank you, Igor, for the kind words there. I see McKinsey saying thank you. Lee says, great topic, knowledgeable panelists. TJ has to run and go teach a class. That's fantastic. Drew says this is definitely changed my perspective. 3D is far ahead of where I thought it was. That is really good to hear. Kevin, I'm going to give you an opportunity to say the final word, and then I will bring us to a close. So, Kevin.
Man, put the spot on me. No, again, I hope it is informative. Again, I appreciate the session, especially the panelists. I mean, these guys are experts and ladies are experts in it. So again, appreciate everyone joining us. I know we're all busy and definitely let us know if it's worthwhile to do these things. But appreciate you, David, leading it and doing such a great job.
Yeah, before I let everybody go, give Kevin some feedback here. Was this helpful? As I asked you, what stood out? Would you like more of these sessions? Please take a moment in the chat, drop that in. I know everyone's got to go. I know we're all busy. The holidays, closing out the year, closing out the month, all of that. Dar would like more. Paul says, thanks so much. Over on LinkedIn, if anybody over there has any feedback, please let us know. If you would like more of these, we'd be happy to bring you more sessions like this. I want to take an opportunity to thank Kurt, Lita, Peter, and Michael. Thank you for your participation today. We appreciate your time. And most importantly, thank you to everybody who is assembled this morning with us. We know that your time is extremely valuable and that it's the most precious asset that any of us have. John, you're welcome, says, thank you, very informative. Tim says, more sessions on 3D printing would be great. Tim, that's good to hear. Douglas says, thank you. Mike says, great session. I would like to attend more. Tony says, very helpful session. Want more detail as to what can be printed. Yeah, I think one of you said that here on the panel. Very interested in the metal side. Well, that is good to know, Tony. Thank you for that. Few more. Give me a few more here, folks. This is good. And if you have to drop off, have a great set of holidays. Appreciate you being here. I'd love to see a few more comments. If there are any more here, I'd like to read that great topic. Very informative session. Thank you. Appreciate that. Lee Reed says that what stood out to him is that we need to learn by doing. because the technology is here to stay and it will only grow. Lee, I think you are absolutely right. Tyson says what stood out to him is the end of life use case and vapor smoothing as an option for post-processing for surface finish. That's fantastic. All right. Thank you, everyone. Thank you, Sean. I see your note there. Thank you, everyone. Thank you again, Kevin, for allowing us to pull this group together. And thank you to Kurt, Peter, and Michael and Lita. We appreciate you all spending your time with us, and of course, the audience as well. Have a great rest of the day, everyone. We'll talk to you soon.
Thanks,
Bye-bye.
everyone.
Thank you. Have a good day.